welcome to my virtual laboratory. So today we're going to discuss the change of phase or state of matter. Are you ready? Alright, so let's start. These are the physical states of the molecules of matter. Molecules can shift from one physical state to another without changing their molecular structure or the chemical state. For example, water is still water when it is ice, steam, or a liquid, even though its physical state has changed. Physical state can be changed by adding energy. How are we going to do that? By increasing the temperature or increasing pressure, or releasing energy by cooling or lowering the pressure. There are 6 ways how to show the change of phase or state of matter. Number 1 is melting, that is changes a solid to a liquid. Number 2 is freezing, changes a liquid to a solid. Evaporation changes a liquid to a gas. Condensation changes a gas to liquid. Sublimation changes a solid to a gas, and deposition changes a gas to a solid.
Experiment time!
Hello everyone! Welcome to our science lab. I'm Argan Arlene
And Miss G over here.
Alright, and today we're going to have an experiment regarding phase of matter and how it changed from one state to another, right?
Yes, it is. Are you excited to have fun today?
Alright, and guess what? We have a special guest today to help us with this experiment. So, come on down!
Mr. Samuel Dell!
Yay! So, Sir Sam gonna help us to perform an experiment today, alright? So, for the materials, we have the following. We have the beaker, and inside the beaker, you have a water, and we have a hot plate here, and it's boiling now. And then we have
an ice in the beaker, an empty beaker.
And then we have here a basin of water with food dye.
We have sugar cane, dishwashing, empty bottle, the graduated cylinder. We have sulfuric acid.
Be careful in using that.
We have the hydrogen peroxide.
Alright?
We have the potassium iodide. And the last one, no, here is the food coloring. And the last one we have here the dried ice.
Alright. So, Sir Sam.
Hello.
What can you say about our first setup?
That looks like it's boiling.
Alright. So,
And that looks like blood.
yeah.
Is it blood?
No,
Oh.
it's just food dye. And what about this one? What can you say about that one?
That looks like it's ice.
Alright.
Is it ice?
Yes, it is. And these are all examples of matter, and we will show you how the phase of matter changed. So from this one, we have solid, and it's starting to melt. So soon this will become liquid like this. And what about Sir Sam? This one is boiling.
It is.
Yes?
Does that mean it's cold?
No, it's hot.
Oh.
And what will happen if it continues to boil?
It would evaporate completely and no longer be there.
Very good.
Perfect.
So that's a change of phase. And then today we will show you more example of experiment to show the phase of how the change of phase of matter happens. Are you ready?
I'm ready.
All right. So let's start, Miss G.
Alright. Sir Sam, here's for you. I hope it fits.
So we'll see how a dry ice change its phase. Miss G, can you show the initial state of dry ice? Is it liquid? Is it solid? Is it gas?
Alright, we have here the dried ice from itself named dried ice. So this is a dried carbon dioxide. And it's dried by a negative 110 Fahrenheit temperature. And what will happen if we're just gonna have to leave it at room temperature? What do you think?
Yes.
Right. So that happens what if we're gonna have to submerge it into a cool water? What will happen, do you think, to the dried ice? Let's find out.
All right, and Mr. Del will do that,
Oh
right?
dear.
Yeah, so you open it first.
Oh, there it is.
So is it the same with this ice? Like this one, as we increase the temperature here, solid will be changed into liquid. And then this one changed from liquid to vapor. But what about the dry ice?
So we're gonna put this Sir Sam to this water over here.
Want that whole
Alright.
big piece?
Yes.
Oh, that's cool.
It is.
Yeah,
cool.
it is.
Oh, should you touch it very much? Are you ready?
No, ready? There you go!
Oh!
So cool. So,
It looks like my living room.
really? So,
Bubbly.
yeah. So what can you say, Sir Sam?
That looks like bubbling blood.
Bubbling blood. That's why this is our Halloween special. All right. So, can you say, Miss G, the change of phase of dry ice?
So if you could see that steam is already found, that signifies that our dried ice from solid state change into a gaseous formation, which is in the presence of this type of smokes over here. See that one?
But you know what? The process of a change of phase in dry ice is from solid to gas. And we call it sublimation process. All right. So unlike the typical ice, it changed from solid to liquid, but the dry ice that Mr. Dell put into this basin, it changed from solid to gas. It transformed from solid to gas, and we call it sublimation process. All right.
Yeah. So the reason why we put it into the water for us to see right away the changes that happens, since we could not see it in a very short time. So this is the reason why we submerge it into the water. So you could see right away the changes that's happening. Now, at a later time, you could see that your dried ice with a big chunk becomes smaller and smaller and smaller. An indicator that it evaporates.
Yeah. It undergoes sublimation process.
Undergoes sublimation process.
All right. So let's proceed to the next experiment. Are you excited?
I am. What do we do next?
All right. So next is the elephant toothpaste.
What?
All right. So let me just remove this one. Just put it here. So for the elephant toothpaste, we are going to see if there will be a release of energy. So we'll be using this graduated cylinder. What else, Miss G?
We will be using, Sir Sam, a hydrogen peroxide.
Ooh.
And it is 30%.
30% hydrogen peroxide. We will be using potassium iodide
As the indicator.
and the dishwashing soap and the food coloring.
All right.
Blood.
Alright,
I
so
will just remove this for our second experiment. All right.
So Miss Arlene, what we gonna have to do? What Mr. Sam gonna have to do first?
All right. So Sir Sam, since we have already here the potassium iodide, you're gonna, the hydrogen peroxide, the 30% hydrogen peroxide, you're gonna put this inside the graduated cylinder.
How much?
All of it. Because
Whoa.
we just have a small amount of that. Okay.
It's not that much. It's
Yeah.
probably.
Yeah. All right. So
it's,
how many?
It doesn't go in 50.
All right. So below 50 ml.
Yeah.
All right. And then the next thing that you gotta add, Sir Sam, is the dish soap.
Oh, how much?
How many squirt?
Just one
2
squirt?
to 3.
Hmm?
2 to 3.
2 to 3?
1,
1, 2, 3.
3. All right. And then the next thing that you're gonna add is the food dye.
Oh, the
Yes,
blood color?
the blood, because it's Halloween.
How much?
Just 2 to 3 squirts.
Squirts?
Yeah.
Yeah. 1, 2, 3.
All right.
Ooh.
So now we go on with the indicator.
This one.
What's this?
That's potassium iodide. That will be our indicator for this elephant toothpaste experiment.
Okay.
Okay.
So a full
teaspoon. Teaspoon.
heaping or just barely?
Which one works?
Yeah, that
for
one.
you?
That one is
Like
okay.
that?
Yeah.
Yeah.
Works fine.
But
So
warning, Sir
heaping.
Sam.
Heaping.
Sir Sam, wait.
I'm
When
waiting.
you put that one,
Yeah.
you need to step backward afterwards. All right, are
You
you
have
ready?
to run.
Not really. All right, how about you? Are you ready?
I'm ready.
Let's
You
do
ready?
this.
Whoa, ready? 1, 2, 3. Whoa!
Okay.
Oh, that's a good one.
Right, there you go.
So as you can see, there's a release of heat energy. So this one undergoes chemical change, and that's how fast it changes its phase from powder form of the potassium iodide and liquid form of the hydrogen peroxide, and now you have the foam, right? And then the setup itself shows exothermic reaction because there's a release of heat. Did you enjoy that?
That was fun.
Alright, so this time Miss G gonna help Mr. Dell to perform another amazing experiment. So are you ready, Sir Sam?
I think so.
Alright, let's go.
So Sir Sam made a preparations of your sugar.
So there's 10 tablespoons or teaspoons?
Teaspoons.
Teaspoons of sugar, and we made a smaller beaker.
Yes. And we will be adding,
This is
Sulfuric
sulfuric
acid.
acid.
yeah, so sulfuric acid is much more dangerous like the hydrochloric.
Yeah,
Ooh,
because it's
dangerous?
corrosive.
Ooh.
So,
So,
I'm putting back in the mat.
right.
so don't do this at home.
So Sir Sam, we're gonna have to pour this one out.
Don't try this at home.
Yeah.
Yes. At least
How many
30 ml.
30?
Yes.
Alright.
Be
So
careful, Sir
just
Sam.
put Sir Sam this one down here.
Down here.
And the, yeah. there
Don't
you go.
touch,
Yes.
but still try to go to 30.
I know. Yes.
180.
Just
There you go.
perfect. There you go.
Exact
just
amount.
exactly amount.
huh?
Yeah, it is.
Cool.
We just measured it.
Yeah.
Oh, haha.
Alright.
Alright, so you're gonna have to pour that one in this beaker and then try to stir them. And after a while,
After a while,
after stirring, you're just gonna have to step back.
not much of a reaction yet.
Alright, so you need to stir it immediately.
Immediately?
Yes. Because later on, we're gonna see the reaction.
Trying to get it all in there.
Ready?
So far, it just looks like mush. Good?
Good? Okay, Sir Sam, ready?
I'm ready. Do I get this out of the way?
Yeah.
Yeah.
So let's see what will happen afterwards.
Looks like
It's a
gooey
caramel.
mush.
Looks like a caramel.
Looks like caramel.
Yeah.
Yeah. A
So
little darker.
yeah, and then let's see what's gonna happen after it turns into a black color. Initially, it's
Oh.
white, right?
It's lighter. It's
It's
getting
white.
darker.
It's getting darker, huh?
Even here on the stick.
Yeah. So what's gonna happen afterwards?
Oh,
Oh.
it's mushy.
Mm-hmm.
I'm not gonna drink it.
It's
I'll
like
tell you that.
a chocolate mousse, huh?
Yeah. Well, no.
It takes a while, so let's
Yeah.
just wait a little longer.
So let's see
I saw a bubble.
how long will be the reaction.
I see a bubble.
Oh, you see a bubble?
I do. I see a bubble.
Oh yeah.
It is going blue, blue.
Okay. So is there a change? Is there a change of phase from sugar to a dark color?
A dark color. It looks at the top like it's getting more liquidy.
Oh.
Am I right or wrong?
Yeah, it is.
And it's still bubbling.
Yeah, so it takes time for it to react. So
So it looks like a chocolate mousse now.
Should I take a spoonful? Wait.
yeah, look at
No,
that
no,
one.
no.
There you go.
Oh,
there.
no!
What is happening?
Abracadabra!
Right.
Abracadabra!
Whoa.
Alright, abracadabra!
Come on.
There must be heat. There must be heat.
Right.
I I see smoke.
Yeah.
Whoa, it's getting bigger.
I know, right? So,
Right.
It's like charcoal.
It's like charcoal, yeah, right?
Look, there's a portion of it starting to try to leave the beaker.
right.
Yes. All right.
It doesn't smell horrible.
Yeah, it smells like a burnt sugar.
Burnt sugar.
Yes.
I think it's going to leave its captivity.
It is.
Is it going to go on the table?
Yeah, so, yeah.
It's a very slow, but it will. So as the whole thing gonna be consumed, so
Yeah.
it will just gonna have to go.
Yeah, so Miss G, is there a change of phase?
Yeah, there is. So from the solid state, and then we add the liquid one, and then
Which is the acid?
which is yes the acid, and then it turns into it reacts with each other and turns into something new, which is a solid form. And aside from that, there is
The release of energy.
a release of energy, which is also found when one substance and the other substance react with each other, and that's sulfuric acid and the sugar.
Yeah, so this one is exothermic also because there's a release of heat energy, all right? And it undergoes chemical change
Right.
because you have a new product.
Perfect. All right, there you go.
There you go. What do you call this experiment?
We have the sugar snake experiment.
All right, so this is the sugar snake experiment, Sir Sam.
That's amazing.
You like it?
I do.
All right.
If
so-
we
And
have
our dry ice is almost gone too.
Yeah.
yeah.
So if we're gonna have to add more sugar, added more sugar, it will gonna grow bigger.
Yes.
So the more sugar added and the more.
Oh, the more sugar,
Yeah.
not necessarily the
Acid.
acid, but the sugar.
Mhm.
So
All right.
Alright, so
It looks like
this
lava.
is hot.
Yeah, it's
so we're
hot.
just gonna have to.
Is it hot?
Yeah, it's
Yeah,
hot.
it is.
Can I feel
Oh no, no, it's hot, Sir Sam.
Super hot?
It is.
Yeah. So
Yeah.
even if you do like that,
It's hot.
Would it be
Burn your
like
skin.
100 degrees, 200 degrees?
you can try.
I do not touch the product itself.
Oh wow,
Yeah, do not touch the product itself
Just
because it's really, really
that's
hot.
very hot.
Yeah, so that is really to show
But
that
it's cool.
it undergoes chemical change, and it's an example of exothermic reaction because there's a release of heat.
Alright,
All right, so
done?
that's it.
Alright, there you go.
Remove
So
the
this
protective
lesson is all about the phase change and the chemical change.
All right.
Bye-bye!